Hey guys, Mr. Backward here. In this video, we're going to look at simplifying trigonometric expressions. As you move into some higher level math classes, and specifically in calculus, there are going to be times where you're forced to deal with expressions or equations that involve some pretty heavy trig things. And some of those trig equations and expressions can start out looking pretty complicated, but it's our goal right now to be able to take some of those more complicated looking trig things and simplify them down so that they're easier for us to work with. So in this first example, we're going to look at simplifying down the expression sine cubed of x plus the sine of x times the cosine squared of x using what we know about our identities and some different algebraic techniques. So in this one, the first thing I see is that we've got a sine cubed in our first term, and then our second term has another sine in it, and I gave you a clue at the beginning that we were going to do a little factoring on this one. So because we've got sines showing up in both of our terms, what I'm going to be able to do is take out the sine of x as a GCF. Now if I have sine cubed and I take one of those sines away, then this is going to turn into sine squared of x plus, now on the back end where we've got this sine of x times the cosine squared of x, we're taking the sine of x out of there, so then we're going to be left with the cosine squared of x. And then I want to look at what's inside of my parentheses, because we talked about a Pythagorean identity that said sine squared of x plus cosine squared of x. And as we looked at that identity, that was just 1. So we can use that Pythagorean identity to replace what's inside of these parentheses with 1. And then if I take the sine of x times 1, then I just get the sine of x. So even though this started out looking like a complicated trig expression, we're able to simplify it down to be just the sine of x by doing a little factoring and then using one of our Pythagorean identities. Now in this example, we're going to do a little expanding and then use some of our identities to help us simplify this down. So the first thing I see is on the top of my fraction, we've got the secant of x plus 1 times the secant of x minus 1. That's a multiplication problem, and we're going to have to do foiling to multiply this out. So if I take the secant of x times the secant of x, then we're going to get the secant squared of x. If I take the secant of x times negative 1, I'm going to get minus the secant of x. If I take 1 times the secant of x, I'm going to get a plus secant of x. And if I take 1 times negative 1, I'm going to get minus 1. And then I'm not going to do anything with my denominator right now. I'm just going to leave that as the sine squared of x. Now what I notice happening on the top of my fraction is we've got a minus secant of x and a plus secant of x. So those are going to cancel each other out. So then on the top of our fraction, we've just got the secant squared of x minus 1 over the sine squared of x. Now what we can do on top is we can use one of our Pythagorean identities. Secant squared of x minus 1 is the same as the tangent squared of x. So I can replace the numerator with the tangent squared of x, and then we've still got this over the sine squared of x. Now what I'm going to do is I'm actually going to split this up. So what I'm going to do is actually separate the numerator off of the top of this fraction. So then this is going to be the tangent squared of x times 1 over the sine squared of x. Now we've got a quotient identity that we talked about with the tangent of x. Tangent is sine over cosine, but this is a tangent squared. So because we know that tangent is sine over cosine, then tangent squared is going to be sine squared of x over cosine squared of x, but then we're still multiplying by that 1 over the sine squared of x. Now we've got a sine squared on the top of our first fraction and on the bottom of our second fraction, so we can cancel those out. So then on the top of my fraction, I've just got the 1, and the bottom of my fraction is the cosine squared of x. Now 1 over the cosine is the secant of x, but since this is squared, then this is going to be the secant squared of x. So we started out with this kind of messy looking fraction, but after we did a little foiling, we were able to use some of our identities to swap some things out, do a little canceling, and then this simplified down to just the secant squared of x. Now in this example, what we're going to do is a little bit of combining fractions, and then we're going to see if we can use some identities to help us simplify this down. So we're taking the cosine of x over 1 minus the sine of x minus the sine of x over the cosine of x. And anytime we're adding or subtracting fractions, we have to have common denominators. So I'm looking at this 1 minus the sine of x and this cosine of x that's showing up in our denominators. And what we're going to do is we're going to multiply each fraction by the other one's denominator to help us get common denominators. So on the left, I'm going to multiply top and bottom by the cosine of x. And on the right, I'm going to multiply top and bottom by 1 minus the sine of x. So what that's going to do is that's going to get us fractions with common denominators of the cosine of x times 1 minus the sine of x. Now on top, if I take cosine of x times cosine of x, I'm going to get cosine squared of x. Be careful when you're doing your distributive property in the second fraction, because this is actually a negative sine of x. So if I take negative sine of x times 1, I'm going to get minus sine of x. And if I take negative sine of x times another negative sine of x, that's going to turn into positive sine squared of x. Now it's maybe a little difficult to see what to do next here, but what I'm looking at doing is rearranging what we've got in the numerator of our fraction. Addition is commutative, so we can do addition in any order that we want. So I'm going to take this plus sine squared that's currently on the end, and I'm going to move that up to the front of my fraction. So then it's going to say sine squared of x plus cosine squared of x minus sine of x, all over that common denominator of cosine of x times 1 minus the sine of x. Now the reason I move that sine squared up to the front is that makes it easier to see one of our Pythagorean identities, because if we take sine squared plus cosine squared in the front here, that's just 1. So the sine squared plus cosine squared turns into 1. We've still got this minus the sine of x, and this is over the cosine of x times 1 minus the sine of x. Now because we've got 1 minus the sine of x showing up on top and on bottom, we're going to be able to cancel that out. So now the top of my fraction, because we've canceled everything out, it's just a 1. My denominator is just the cosine of x. And 1 over the cosine of x is the same as the secant of x. That's going to be it for this video. Thanks for watching.